In this video, we are going to factor the greatest common factor out of a polynomial. So ultimately what we're going to be able to do by the end of this lesson is we are going to be able to take polynomials that are written in standard form. So written so that there's no parentheses involved. And we're going to be able to take these polynomials written in standard form and turn them into factored form, specifically factored form that involves bringing a monomial factor and pulling it out in front. Basically, what we're going to do today is we're going to undo the distributive property by doing something called factoring out the greatest common factor. So that's our goal today, to take something written in standard form and factor out the greatest common factor and write it into factored form that involves multiplication and parentheses. So in the examples below, we're going to factor out the greatest common factor. Now, a couple of things we need to remember as we do this. First, a common factor, remember a factor is a number that evenly divides another number. Now, if we're looking for a common factor, we're looking for one that all the terms that we have are divisible by. So when we're looking for a common factor, we're looking for a number that both of the terms are divisible by. Now we're also going to look for the greatest common factor. So this means we're looking for the biggest number that both of those terms are divisible by. So if we look down at 12 and 32, what I notice about 12 and 32 is they are divisible by a couple of common numbers, but specifically they are both divisible by 4 as the biggest number that they have in common. So what we're going to do is we're essentially going to undistribute 4. And I like to do so by drawing a line underneath and saying, okay, we're going to undistribute 4. So we're going to divide each of these by 4, and we're essentially going to pull this 4 out in front of a set of parentheses. Now when I think about this, if I'm going to undistribute the 4, I need to take 12 divided by 4, which is 3. And then I leave my x tacked on. And then I take 32 divided by 4, which is 8, and leave my y there. So what I've done here is by factoring out the greatest common factor, by undistributing that greatest common factor, I'm able to rewrite this expression in a different way. Now notice that if we distribute back in, we end up where we started. We get 4 times 3x plus 4 times 8y. So we would get 12x plus 32y. So I haven't changed the integrity of the problem. It's just I've rewritten it in a different way. So I've essentially undistributed and rewritten this expression in factored form with parentheses and multiplication. Now from here, if we look at the second example, what I notice in this second example is that the greatest common factor between 20 and 16 is also 4. The biggest number they're both divisible by is 4. But what I also notice about these is that they have some variables in common, unlike this first example here. What I notice is that 20 contains x to the third and 16 contains x to the eighth, which means they both at least contain 3 x's. They contain an x to the third. So what I can also do is factor out an x to the third because they at least have an x to the third within them. This one has 8, which is more than x to the third, but we can only take out what they have in common. I then also notice that they both contain y's. This one has a y to the third and this one has a y to the fifth. The y to the third is the smaller one, so I can factor that out as well. So as I'm factoring out greatest common factors, I'm also going to think about the variables that they have in common. So here, as I rewrite this, I'm going to factor out or undistribute 4x cubed y to the third. And then I'm going to figure out what terms are on the inside so that if I were to distribute back in, I would end up right back where I started. Well, 20 divided by 4 gives me 5. The x to the thirds completely cancel. And the y to the fifth over y to the third, well, 5 minus 3 is 2, so I'm left with y squared. And then here I'm going to use keep change, so I have plus a negative. Well, 16 divided by 4 is 4. X to the eighth over x to the third, we just subtract 8 minus 3, which leaves me with x to the fifth. And then the y to the thirds completely cancel out. So here we've rewritten this into factored form, and notice that if I were to redistribute that 4x cubed y to the third back into the problem, then I would end up right back where I started. So let's do a couple more examples together. If I look at 40 a to the 7th b plus 8 a to the 4th b cubed, what I notice is that both 40 and 8, their greatest common factor, well, they have a number. They have 2, they have 4, they also have 8 in common. Both of them are divisible by 8. So I'm going to divide both of these by 8. Then from here I look at their variables and I notice we have a to the 7th and a to the 4th, which tells me that each one at least has an a to the 4th. And then I notice that I have a b to the 1st and a b to the 3rd, which tells me that each one at least has a b to the 1st. So as I'm factoring out my greatest common factor, I'm looking for the greatest common numerical factor as well as any variables that they might have in common and how many they at least have. So here if I factor out 8, a to the 4th, b to the 1st, I then am left with 40 divided by 8 is 5. Then I have a to the 7th over a to the 4th. 7 minus 4 is a to the 3rd. And then the b to the 1st cancel out. Plus 8 divided by 8 is 1. The a to the 4ths cancel out. And then b to the 3rd over b to the 1st, we take 3 minus 1, which is b squared. So again, if I were to redistribute that 8 a to the 4th b back in, I would end up right back where I started. Now if we look at the next one, here I notice we have 28 and 16. The greatest common numerical factor that they have in common is 4. I then look at their variables and I notice that they have x's. This one has 2, this one has 6, so they have at least 2 x's. They have at least 4 y's, and they have at least 3 z's. So then I can factor out 4x squared, y to the 4th, z to the 3rd. Then to figure out what's on the inside, I take 28 over 4, which is 7. The x squareds cancel here. The y's, we get 7 minus 4, so we're left with 3 inside, and the z's cancel. I then have plus a negative 16 divided by 4 is 4. Then I have x's with 6 and 2, so 6 minus 2 leaves me with x to the 4th. And then the y's cancel, and the z's cancel. So there's my final factored form. Alright, final two examples here. This first one, you'll notice that they both contain negative numbers. The best thing to do when you factor out the greatest common factor is if they're both negative. Factoring out a negative can actually be very, very helpful. So here as I look at negative 18 and negative 24, I'm going to use keep change here, I notice that a negative 6 is something that they are both divisible by. I then notice that they both contain at least 3 m's, and they both contain at least 2 n's, the very minimum. So now if I factor out negative 6m cubed n squared, so I'm undoing that distributive property there, negative 18 over negative 6 leaves me with 3. Then I see that the m's cancel and the n's cancel. I then have plus negative 24 over negative 6 is 4. And then notice that I have 8 minus 3, so m to the 5th, and then 4 minus 2, so n squared. And final example here, I notice that I have 3 terms. So here I have 20, 16, and 4. So I need to find the greatest common numerical factor for all 3 of them, which all 3 of them are divisible by 4. I then notice that they each then have at least one x and one y, to pick the very minimum there, because I have to pick what they all have in common. So what I see here is I can factor out 4xy. So as I do that, 20 divided by 4 is 5. X to the 3rd over x to the 1st, 3 minus 1 is x squared. And then 5 minus 1 is y to the 4th. And have plus negative 16 over 4 is a negative 4. 8 minus 1 is x to the 7th. 3 minus 1 is y squared. And then have plus 4 over 4, which is 1. Then the x's cancel and the y's cancel for just 1 there. So there we have it. Notice that here, even though we factored out this term, and even though it just divides out to be 1, the 1 is still in that problem.